Hi, I'm Anushubin Joseph Raj. I am a lead software engineer at OpenText, and this is our submission for the Hacknosis 2024 hackathon. And the title of our project is EcoJobber AI, and it is an ecological AI job scheduler. We have done it as a team of three members, including me and my teammates Satya and Sriram. Here is the agenda for today's presentation, and we start with objective, demo, implementation, applications, and in the end, the future plans of how we can improve the application. Let's start with the objective. So as you can see, the objective of this project is to understand how we can identify jobs and assign them to particular time slots where the ecological impact of running the set jobs will be the least on the environment. So we have identified by research that running certain jobs at running certain jobs at different time stamps or time slots in a day uh, affects the environment in different ways. We'll be explaining that in a future slide. So that is the ideology, that is the basic idea of our project. And we are using artificial intelligence to predict which would be the best time of the day to run the jobs. And we are using open source data. So all of the data that we are using to figure out which would be the right time is dependent on fast open source data. And then we use parameters such as carbon intensity and carbon consumption, which is tied to a location, a geological location in the map, to figure out the metrics. Moving on. So let's go directly into the demo. So this is the dashboard of our application, and here you can see the carbon dioxide consumption comparison versus carbon dioxide saved per day. So in this chart, each blue bar represents how much it would have consumed if it were scheduled using conventional methodologies versus how much it was consumed based on EcoJobber. So you can see the difference is 55 minus 41, which is equal to 14. So this chart on the right side actually says the difference between each graph. So you see on 2nd January, all 70 of them were saved. This is actually a mock data. It's not real-time data. We will be adding real-time data in the actual project. And here you can see we have a small graph which shows how many print or scan jobs were performed every day. This data doesn't directly impact our application per se. This is just there for some statistics. And now to the main part, we have the scheduler. So the scheduler consists of three sections. There's a section where you can add a new job, and there's a section which lists existing jobs, and there's a section which lists machines. That is the environment where each job can be run. Okay, so let's start with the add a new job section. Herein we have parameters like urgency, zone, deadline, kind, and distributable. So urgency is as it says how urgent the job is. So let's say I am having a highly urgent job, and then I pick a zone. So the zone can be anywhere in the world. So this list of zones is obtained from the actual API itself. So let me pick one zone in random. I have chosen Armenia, and the deadline is supposed to mean when the actual job has to be completed. So let's say it has to be completed within today. So I choose that. And then the kind of job is what kind of job? Is it a print job, scan job, or any other jobs? Okay. And then we have this option which asks whether it's distributable or not. So what this essentially means is that whether you can run this job elsewhere in the world. So should the originating zone match the actual zone where the job is run or not? That is what this distributable flag stands for. For example, a print job should be run in the same zone, so you don't select distributable. Let's say I am doing some other job, for example, running a 3D model for something, and or maybe a rendering job that can be run anywhere on the world. and it doesn't matter whether it's being run on the originating zone. So let me add this job, and you can see here a pop-up appeared saying that job ID and the ID of the job successfully created. So you can see the job ID ends at 924F6. So if you go to jobs, you can see that here 924F6, and you can see the job got created with status of created, and now the scheduling has started already. So in scheduling, what it does is it figures out what is the best time to schedule the job, and then it schedules the job. So it has scheduled it now, and you can see that it got scheduled to 1921. So this time is in UTC plus 0 format. I am in GMT plus 5 in India actually, but the times that are being showed here are in UTC plus 0. So this is the creation time of the job, and if you see closely, it has been scheduled 5 minutes after the creation job, uh, mostly because of the urgency. We have given a high urgency job, so it got scheduled in as early as possible. Now, the machines are the ones where the jobs can be run. So we have two machines, two printers actually, and this is the zone where the printer exists. For now, we do not have any link between the originating zone and the zones where the machines are available. It is supposed to schedule a job in a machine where which is present in the originating zone, because we said distributable is no. So that is that. So back to the PPT. Now let's look at the implementation. The implementation consists of 3 steps, and step 1 of it is receive. So at the receive step, we actually receive the data from every entity in the system. We have taken as example a medical institution, such as a hospital. We have multiple entities like doctors, lab assistants, cashiers, pharmacy, and their own IT. And what we do is we collect the jobs from each of this entity and store everything into EcoJobs AI. So anytime any of this person schedules a job, it doesn't go directly to the machine. It goes to the EcoJobber server. And once the receive is done, it's step 2, which is analysis. In the analysis step, it analyzes which is the perfect time to run the job. So for example, you can see here we have a data of Ontario, Canada, and you can see that between 9:30 to 3:30 p.m., there is a small dip in the consumption of carbon dioxide. So if we schedule a job within this time frame, that would be the best, because if I schedule the job in any other time, that would consume a lot more carbon dioxide. So this is what is the prime focus of our project. So this data is obtained from an open source location, which we will see in the next slides. And I'll show one more example. This is in USA, and you can see here also throughout the day, the spike is very high, but at this specific time frame, it's like almost 0. So scheduling a job at this time frame will greatly help the environment. So this is the API which we have used. It's static.electricitymaps.com, and they have given us the API key for use for the hackathon, and they have also given the documentation saying how to use the API. And after the analysis is done, step 3 is schedule. So in the schedule step, we actually schedule the job to the perfect time, and then EcoJobber server itself takes care of invoking and running the job at those specific times. So the whole control from end to end, from getting the job from the user till the job is being invoked in the respective machines, everything is taken care by EcoJobber. Now let's look at the applications of the product. So as we saw in the previous examples, scheduling printing of reports is one of the major application. As you know, printing consumes a lot of energy, and if we schedule them to run at downtimes, or like the times where the carbon intensity consumption is having a dip, that would be very useful. And other than that, we have routine backup and archival jobs. So any system in a production environment goes through routine archival jobs and backups as well. And run running those scheduled jobs via EcoJobber will also help the carbon dioxide consumption go down. And similarly, you can use it for data intensive research computation, like how I said about 3D models. Even medical facilities use computational models to figure out medicines and drugs, the chemical combination needed to produce a certain drug. So that is also uh, scheduled, that also can be scheduled to run at specific time. And the software updates, which are another routine job for every medical device, those can also be scheduled using EcoJobber. Now here we have the future plans for our product. As you can see, the current demo was prototype, and it's not fully integrated with live working systems. So the first future plan which we have is to integrate it with live working systems instead of using mock data. And those systems will we'll have to do hardware integration. For example, to run a print job, we will need to have direct hardware access to the printer. So that is something we'll have to do. And it's not just about printing, it's also about invoking any kind of job. For example, um, as I said, the 3D model rendering. So that should be done maybe on a supercomputer or something which resides somewhere else in the country. So those kind of API invocations also need to be integrated with our application. So we will probably provide an interface to the developers of those machines so that they can do an end-to-end integration between EcoJobber AI and the actual hardware. And then the next one is to provide time picker for the deadline. So if you had seen the demo closely, we could only select the date for the deadline. There was no time, so you cannot select, for example, I need this job done by 5 p.m. today. So that is something we'll have to look into, which is a minor thing. We'll do that next. And then fix the time zones in data display. So as I said, all the time this displayed on the website are in UTC plus 0. But when an user sees the website, they should be able to see it in their own local timestamp. So that is one more thing which we have in charts, and we'll be doing that. Thank you for staying till then. Hope you liked the project. If you have any more doubts or suggestions, please reach back to us, and see you soon. Thank you. Bye.